Hey everybody, I wanted to look at a few of these problems from the Intro to Direct Variation slideshow. Some of you were having trouble with these. So it just says, here's an example of direct variation. So it's telling us that it is a direct variation. And it wants to know what is the constant of variation from this table. So the way that we need to do this is by dividing. So for direct variation, we need to divide. So I'm going to find the constant, I'm going to do y divided by x. Okay? So for my first one here, I'm going to do y negative 1 divided by negative 4, which simplifies to just 1/4. For my next one, I'll do negative 4 divided by negative 16, which also simplifies to 1/4. And then for the last one, if I do negative 10 divided by negative 40, you guessed it, it also simplifies to 1/4. Okay? That's why this is called the constant of variation. It's constant because it didn't change. So constant stays the same. So my constant of variation for this problem is 1/4. Okay, so that was the first example. For this example, same thing. It tells me that it's a direct variation, and they want to know the constant. So I just need to divide them to see what I get. So let's do that. All right, so same thing for direct variation. I need to divide. So I'm going to do y divided by x. So I'll do 10 divided by 30, which reduces to 1/3. For my next one here, I will do 5 divided by 15, which also simplifies to 1/3. And then, for my last one, 3 divided by 9 also simplifies to 1/3. So my constant of variation for this problem is 1/3. Okay, so that's the way that we calculate constants of a direct variation problem. This one is slightly different than the previous two because it's asking, is this a direct variation? So in the first two, they told us that it was a direct variation. This time, it's asking us. So the way that we can do that is the same way we did. We still want to divide all these and check them. So for my first one here, I'm going to do y divided by x because direct, divide. So I'll do 6 divided by 4, which simplifies to 3/2. So in order for this to be a direct variation, hopefully all of these other 3 are also going to give me 3/2. So let's check this one. 12/8, 12 divided by 8. So 12 and 8 will both simplify by 4, and I still get 3/2. Now, don't get too excited. Sometimes the others will be wrong, so we still have to check all of them. So I'll do 18 divided by 12. Both of these reduce by 6, and we still get 3/2. So it's looking pretty promising now, but let's check the last one. 27 divided by 18. Both of these divide by 9 to give me 3/2. So is this a direct variation? Yes, it is, because every time that I tried to calculate the constant, I got 3/2. So my constant here for this is 3/2. Now, if I wanted to write this as an equation, my equation would be, actually I'll do a separate little box because it, constant variation and the equation. So the equation for a direct variation is y equals kx. So it looks like a line, just kind of like y equals mx plus b. This is sort of the same thing. We're just using a k instead of an m to represent the constant, but it's really the same thing. So in this case, since my constant was 3/2, I would have y equals 3/2 x as my equation for this example. Okay, this is the last one that I'm going to do. So same as the last one, is this a direct variation? If yes, give the constant and write the equation. So calculate the constant of variation for a direct variation is to divide. So for this first one, I'm going to do 5 divide 15. 5 divided by 15 simplifies to 1/3. So in order for this to be a direct variation, all of these other ones need to also simplify to 1/3. So I'm going to do 26 divided by 3. Guys, I have no idea off the top of my head what 26 divided by 3 is. But I can tell you what it's not. It's not 1/3. So there is no need for me to even finish this problem. As soon as I get something that doesn't match, then I say, no, this doesn't fit that pattern. And actually, I'll calculate it. See, 26 divided by 3 is apparently 8.6 repeating forever and ever and ever. Okay? So since they're not the same, I can say, no, this isn't a direct variation. Okay? A constant has to be just that. It has to be constant. I hope that helped a little bit. Let me know if you have any other questions.